Hey guys, welcome back. We're here looking at an example from chapter 11 in the textbook, and this is going to be our example involving linear regression. So the whole idea with linear regression is that we have some data which consists of x values inputs and y values that are outputs. And we want to look at the data we've got and see if we can use this data to predict if someone comes along with a new input, what sort of output they might get. So for this example, we've got some students taking a test, and on the left here, the x values, we've got their study time, how long they studied for the test, and then we have the scores they then got on the test. So what we want to know is what sort of relationship do we have, and can we use this relationship to predict, okay, if someone studies for a certain amount of time, what kind of score do we expect they're going to get on the exam? So it's important to keep in mind here that the study time is the input, those are the x's, and the scores themselves are the output. Those are the y values. So you might remember from a high school algebra class or something like that, in order to determine a line, you need two things. You need a slope and an intercept. So I've got this set up here, and the nice thing is Excel will actually give us both of those things. So if we look at the slope function, what the slope function wants is the known y's, in other words, the y data you have, and the known x's. It asks for the y's first for whatever reason. So these are my y values, fills in like that, and these are my x values. And then it gives us a slope of 3.5. So what that tells us is, first of all, that's a positive slope, like we'd expect. The more you study, the higher score you get, and that seems to be consistent with our data. And that basically tells us that for every hour you study, you should expect your score to rise by about 3.5 points. And then also the intercept, same deal, we have equals intercept. And again, it wants the y's and the x's. And so the intercept is the value that you expect to get when you plug in an x of 0. So in our particular example, this is the score that the student who didn't study at all would expect to get. So using our line for predictions, we can say, okay, suppose I have a student who says, I studied for 10 hours. What do we expect that this student will get on the exam? And so just like regular lines, if you've got an mx plus b, what we're going to do is take our 10, multiply it by the slope, and add the intercept. In other words, we're going to do equals slope times the x value plus the intercept. And so we see that a student who studies for 10 hours should expect to get a score of 55 on this test. Now, the nice thing is Excel also has a function that will do that for you automatically called forecast. So let's just see how that works so you don't have to remember how to use the line. You say, okay, I'm going to do the forecast function. And it'll say, okay, x, meaning what's your new x? So we say, okay, our new x is 10. And what are your known y's? Those are these values here. And then what are our known x's? Those are the same values there. And so it gives us the same answer. So forecast is a nice function that'll do the prediction thing without you having to manually find the slope and the intercept. You can just say forecast based on this data. Now, one of the things we like to compute when we have a two-variable data like this, when we have a regression line, is, okay, we have an actual point of data where we have an x value of 12 and a y value of 60, and then our line says that you should take your x value multiplied by 3.5 and add 20. So what I want to enter in here is, given the x's that we have, instead of the y's that we actually got, what would our model forecast for them? So what I'm going to do is say, okay, this is going to equal forecast again. But I'm going to say, enter in an x, one of the x's we actually have. And then the y's and the x's. And we see 62. So what that tells us is, if someone tells you they study for 12 hours, our model suggests that they should have gotten a 62. Now this person actually got a 60, so they did just a little bit worse than our model would have predicted. And I'm actually going to copy and paste this down, but now I need to put in dollar signs so that I won't move my y's and x's, even though I'm going to move my input x here. So I'm just fixing these two arrays. Didn't change the value at all, of course. And now I can just copy and paste this and look at the forecast values for the various x's. So here in row 3, I've got, okay, if you study for 8 hours, our model suggests that you should have a 48 score, and this guy got a 50, so he got lucky. He got 2 points more. So then the question is, how different are the values we predicted from the actual values we have? So these are called the residuals for each point on the graph. So the residual is how different the actual value is from our predicted value. So someone with a score of 60 actually got lower than the model predicts. So I'm going to take the actual value and subtract the predicted value. And you see that this is a residual of -2, and what that means is this person scored 2 less than we thought they maybe should have. So copying and pasting here, this down, we see that we have the residuals of -2, 2, -1, and 1. And you know you've done this right when this adds up to 0. In other words, the regression line we've got, the slope 3.5 and intercept of 20, is the line that will make all these residuals add to 0. In other words, some of the points are a little under, like this guy's 2 under. Some of the points are a little over, this one's 2 over, but they all average out to be just right. And so you can check that and go, okay, what's the sum of my residuals? And it's 0 as it should be, which is a good check that you've done your residual calculations correctly. So just like with computing the variance, when you have the residuals, you actually, what you really want is the squared residuals, because if you just add up the residuals, you get 0, so that tells you that, well, maybe what I ought to do is add these numbers up after they're squared, and that'll give me some more information, because squaring a number will always make it positive, so therefore I'll have something useful. So this is called the sum of the standard errors here. So that's going to be equal to the sum here. And so the sum of the squares is 10, and then the number we're usually interested in here, this is the standard deviation of the line, this is going to be equal to the square root of that number 10 divided by n minus 2. So how many points you have, in our case we've got 4 minus 2, because we're losing 2 degrees of freedom, so that gives us a standard error of 2.236. And that tells us sort of something about how far away we'd expect our predictions to be. So this tells us something about how confident we can be in our predictions. Another estimate that tells us how confident we can be in our predictions is what's called the correlation, and that's always written R. So right, R equals coral is Excel's abbreviation for correlation. And array 1, array 2. This one, unlike the forecast and slope, you can enter them in either order. And that is 0.9899. Now, the correlation is a number that ranges between -1 and 1. The closer that number is to 0 is the less strong the relationship is between the two of them. And then the closer it gets to -1, the more negative relationship you see. And the closer it gets to +1, the more positive relationship you see. So we've got a number that's very, very close to +1. It's 0.9899. That suggests that there is a very strong relationship between increased study time gives you an increased score on the test. And then because this number can be positive or negative, again, a lot of times we square it. So this will be equal to, let's see, that looks like E10 squared. And lo and behold, we get 0.98. And what 0.98 here tells us is there's variation in the y-scores. There's variation in the scores that people get on this test. And the question you want to ask is, well, if I know how much they study, will that eliminate some of that variation? Will I be able to make a more informed guess? And the closer r squared is to 1, it's telling you what proportion of the variation goes away if you take study time into account. So what this r squared being close to 1 is telling me is that, oh yeah, knowing the study time is a very important thing to know if I want to make good predictions about the score. If I'd gotten an r squared closer to 0, I would have said, well, it turns out no matter how much or little you study, doesn't really seem to matter. So on your homework this week, you'll be asked to do all these sorts of things. Find the slope and intercept of the regression line, just using the slope and intercept function. Predict the value for a new x value, right there. Compare the actual y values with the forecast values that your model suggests. Find the residuals, add up the squared residuals, divide by n minus 2 and square root, and finally compute the correlation and the correlation squared, the r squared. And I want to do one more thing because I know some of you are going to be using this regression analysis on your project. So I want to show you one more thing that Excel can do with this data, and that is actually graph it. So selecting the data, and I'm actually selecting the words here because Excel is smart enough to include that in the chart. And I'm going to select scatter plot. And notice when I mouse over scatter plot, it says compare pairs of values. Well, that's exactly what I want to do. And it says, well, I've got a couple ways I can do this, straight line scatter. I'm just going to go with the most sort of standard marked scatter and see what that gives me. And so there it is. There's my 4 points of data, and you can see here's the poor guy that only studied 6, and he got 40. And you can mouse over these things and look at, oh yeah, there's the score you got there. But even better, the charts will give you the actual trend line. So this line we got with slope of 3.5 and intercept 20, this is a great way to check that we've computed this line correctly and to actually see it in action. So I'm going to go down to trend line, and I'm going to say linear trend line. Tell me what this data looks like as a trend. And there it is. So there's the straight line that gets as close as it can to all these data points. And furthermore, Excel is smart enough to say, well, one thing you might want to see on here is the equation. Display the equation on the chart. And even better, you might want to take a look at the r squared. So this is a great way to check the numbers that I've gotten here. So this says that, oh, the line you're looking for, the line that best expresses the linear relationship in this data, is the line y equals 3.5x plus 20. So that's a line with slope 3.5, check, and intercept 20, check. Also, this relationship has an r squared of 0.98. Oh, good. That's what I got as well. So bringing up this chart, not only does it look nice, but it's a nice way to check that you've done your regression correctly. Anyway, so thanks, and I will be looking forward to taking a look at this homework from you guys. Talk to you later.